I think Mark's comments are a perfect segue to where I'm headed. And I've often talked about Sagrada Familia as a sort of a perfect example of model-based design and the evolution that we've gone through. So I'm going to jump right in here. I can't separate technology from the perspective of those people who are going to be using it in the future. In particular, the young architects, especially the students of architecture here in the school, you know, are basically of a class of folks that we sort of characterize as the millennials. And as such, you think differently than we do, than my generation, than many of the generations you're going to hear speaking today. You think differently, you act differently, you will work differently. The whole culture surrounding technology is different and evolving, and you're part of that process. When you start looking at the characteristics of the millennials, the folks who are going to absorb, use, and otherwise deal with this, you know, you guys have always dealt with things that are technologically driven from a different social perspective than we had. I mean, the Cold War never existed. You may or may not have ever used a stamp. You know, the whole concept of texting is actually part of your phenomena rather than email. You know, for us it's death by email, but you are instant gratification, instant messaging, and it's a whole different communicative process and collaborative process that we're all dealing with. You also have a global perspective that earlier generations never had. The ability to be able to communicate and collaborate and work on a worldwide scale and a worldwide scope today exists where it never did before. You know, you only know Germany as one Germany. You've never experienced some of the things that we've experienced in terms of the evolution. You know, I like this one. You know, McDonald's has always served a Happy Meal in China. You know, that's not really a technological issue. It's an issue about the global perspective that you know, our culture has come across now. And you're technologically savvy. You know, Google has always been a verb. You know, the kinds of interactions when it comes to cell phone technology and other things had been normal to you. You grew up with a World Wide Web. You've never used an 8-track. You know, those kinds of things are different. You've always seen flat screen TVs. You never dealt with tubes. You know, GPS has always been around. Those kinds of enabling technology and those kind of cultural issues that empower the use of technology are really, really part of the enabling concept around it. So let's talk about how this comes together. You know, I'm an architect, so my perspective here is going to be around architecture, engineering, and construction, much about how the building design process is ultimately culminated in the execution of a building. This is actually my personal brain, so I talk about this in terms of the fact that information is part of the dynamic that we have to deal with. The ability to assimilate huge amounts of data and huge amounts of information is a phenomenal process. So I use a product that helps me do that, and it collaborates everything together and relates everything in a non-linear fashion. And when we look at technology out there, it's a diverse environment. This is actually a sketch done a few years back by SOM, and this basically helps diagrammatically show about 50 different pieces of software that SOM uses in their practice to be able to come up with the design and execution of a building as architects and structural engineers. You know, interoperability between software is a huge issue. It's basically, they don't care what they're using. They use whatever tool is necessary for the purpose in which they're going to try to accomplish something. They'll leverage everything and anything to accomplish what they need to do. Now, in the world we look for, you've heard this mentioned already, complexity in design is a given. There are no easy solutions that exist in our world anymore. And design complexity is part of the way we solve some of the problems we're going to have to deal with. That's a normal. That's a normal thing that we're going to all face, that you're going to face, that technology has to help with, at least from the perspective I bring. And linear design, both in terms of a process and the form, is going to be diverse. Non-linear, non-orthogonal, organic, you know, is normal nowadays. Okay, partly because we now have enabling technologies to both design it but also to fabricate it and build it. So this is the culture of what we see, what we're actually producing. And from my perspective, the world will be modeled. Okay, make no mistake about it. Model-based design is where we all started as a profession of architects, and that's the true root of where we're returning. And it's everything within a building. Buildings are much more complex than they've ever been in the past. But the entire world, as we know it, will be an assimilation of models that represent the virtual realities we deal with. Because design and simulation are going to be part of the culture that we deal with. So when we look at this, how do we gather this? This is an important piece. You know, laser scanning and photographic, methodologies now to produce point clouds are becoming the norm. Out there today, Google is now replacing all of their photography with trucks that are out now driving about 70 miles a day doing high-definition laser scans of streets so that the next generation of Google Earth is actually going to be a 3D model of all the spaces that we see. You know, those are the kinds of enabling technologies to be able to scan an existing building and basically create it visually and virtually as you start to modify it, are part of the enabling technologies that we all deal with. That is the reality that we face. And make no mistake about it, we deal in a true global crisis when it comes to sustainability and resource management. We talked about it earlier, and I appreciate that point of view because don't put your head in the sand. There is not a single thing you're going to do in your lifetime or the rest of your lifetimes that doesn't have to take into account the worldwide perspective of sustainable design practices. And to not take that into account is socially irresponsible, okay? Absolutely important, absolutely critical, and it's a worldwide issue. It's not just a local phenomenon, and it's not going away. This is not a fad. This is real. And we're going to be looking at design as we talk about the, being able to design virtual buildings from a life cycle perspective. Okay, buildings are no longer things you tear down and destroy and put into a landfill at the end of the day. Okay, the technology around life cycle design for products is making the transition to buildings now. So deconstructing a building and reusing the parts and pieces of a building is part of what you're going to be designing around. Life cycle assessment and making decisions about the selection of materials in the beginning of a building that may last 50, 100 years is going to be commonplace. Assessing the true life cycle of every piece and component within a building and understanding what it's effective on human, toxic environments, ecology, everything you can think of, energy use. And all input's going to occur once. The whole concept around model-based design is that you leverage what you input. The idea of repeated input and repeated work by different folks actually needs to go away. The construction industry is hugely inefficient, and this is one of the reasons. We have a lot of redundant, repetitive work. So the idea is to leverage the work. The engineers are going to leverage the work of architects, structural engineers, the contractor then going to leverage the design level, and then ultimately owners are going to leverage the design information that we provide them in the virtual models. That's part of the life cycle that we're going to see in a model-based workflow. And even understanding codes and regulations and all the other nitty-gritty things that actually have to be accomplished as part of the building design process are going to be enabled and supported by technology. Now, it's an absolutely important understanding that this doesn't replace intelligence. What this does is enable decision-making and help take away the parts of the decision-making process that are mundane, redundant, and otherwise not effective. And collaboration will be virtual. So yes, I'm a Hokie, so I apologize to all of you who are from Michigan. But nonetheless, when we look at virtual environments, collaboration in a virtual world and virtual tools is going to be the norm. Whether it's simply face-to-face using Cisco-type products or things like Skype, or we're actually talking about caves where you can actually do virtual walkthroughs or other types of simulation, they're normal. And everything is going to be analyzed in basically real time. You're going to look at the future of a building design and be able to say, as I orient the building slightly 5 degrees, clockwise, what's the impact on my thermal performance? What's the impact on my daylighting? How does my building react in this environment? How does it compare from one site to the other? How does the mass and the form of the building react? I want to virtually predict what the performance of that building is going to be like through its 50-year life cycle. And I need to do it fast enough to make real-time decision-making processes work. And it's all about making intelligent decisions early in the design process. We're going to measure our buildings, even existing buildings. We need to understand exactly how they function, and there are now tools, even wireless tools, to be able to measure exactly how a building's performing, not just metered at the point of the electric load. That's where most of our existing buildings are today. Real-time coordination and clashes. Now, this may not be something you guys deal with, but this is where the construction world meets the design world in terms of executing those things that we create from a design perspective and the frustration the contractors and subcontractors often have to deal with. Visualization is going to be 3D. You've already seen the phenomena. You know what the impact of even the entertainment industry has had on things like Avatar and how that's affected things. But the evolution of 3D screens and 3D visualization is continuing to evolve. We've only cracked the very, very beginning of that technology. It's going to be amazing. And even flat is 3D. I love this example. If you haven't seen it, you can look it up on Google and YouTube. This is a company called Zebra Imaging. They make holographic flat prints. You can literally move around visually inside of a building looking at a flat 2D object. It's an amazing technology. They're the only ones that make it. It's an expensive technology, but it's really, really different from anything you've seen before in terms of being able to visualize environments. We've talked a little bit about rapid prototyping, and Mark mentioned it, so I'm not going to go into great detail other than to say that it's absolutely true. The ability to be able to respond quicker, have discussions with owners, understand the implications of our process, and be able to communicate is a rapidly changing environment. And we're dealing in an environment where the entire team collaborates. And this is not necessarily about technology, but technology is an enabler to be able to have these discussions among individuals and to be able to work in collaborative modes that we've not been able to in the past. And I like to call it construction will be a team sport. Literally teams will be able to work together, and this is a real example. The construction team, the entire subcontractor team sit down every Monday, go through a virtual model, a virtual schedule of the building, and they know exactly what's going to be happening that week and be able to predict exactly what's happening. And they tie that all to basically a virtual schedule. The entire world is also going to be connected. You may not realize that Hughes has 3 satellites that cover the entire Earth. And with something that'll fit in a backpack, any job site, any location on the entire Earth can get internet access. Okay? It's phenomenal technology, phenomenal step forward in terms of the way we do things. Scheduling is not going to be a Gantt chart. It's going to be photorealistic. We're going to understand things. This is how we communicate to the public what our design intent is, communicate to design professionals. It's all about being able to realistically represent the building in the future. And we're not just going to be modeling the buildings, but the entire construction process. Contractors already use it today to model everything from scaffolding to cranes to temporary facilities, in this case surrounding buildings, access ways. This is all part of the process of construction, and it's not just going to be the building environment that we work in. We're going to be able to estimate in this environment. We're going to be able to look at the concept of prefabrication at a much, much higher level. These are different technologies. Most of this is actually out of Europe, where entire prefabricated concrete systems are done strictly off of digital models, all the way from rebar bending to pouring and mixing concrete to finishing to breaking down the formwork. Another variant on fabrication. In this world, this is about ductwork. You see this in curtain walls nowadays. You see it in ductwork. You're going to start to see it more and more on a regular basis. I'll actually flip through this pretty quickly because I've got a short time. You can see how this workflow is actually all digital. and even rapid printers now are not necessarily about prototyping, but actually producing the products that go into buildings. You know, actual digitally fabricating into metal and into technologies, where you're going to see what you see in the model is what you see in construction. Thank you very much.